Hey class, how's it going? We got helpful video number 1 of our last week of new content. So hopefully that feels pretty good. Again, this helpful video and this week will be the last new content you'll have for our semester, okay? Alright, so in our last thing, we're only really actually going to focus on one kind of topic, and that's refraction, okay? So that's kind of refraction. Last week we talked about waves, we talked about reflection and diffraction and what those are and how to show them. This week's going to be all focused on refraction and what it means and how to kind of manipulate it and work with it for our numbers and angles, okay? This week you will need as well still your protractor and your ruler, so keep those. You can bring back them later. If you don't have one yet, I have them here if you need to borrow one, okay? So come on down and grab one. Alright, so what is refraction? Well, the basics of what refraction is, it is when a wave, either sound, light, or water, or any kind of wave, enters a new medium, it's going to bend, okay, and it's going to change. Actually, it's going to change in 3 ways, and I'll talk about that when I put a picture up. But basically, when waves enter a new medium, they change in a few different ways, okay? The best example that you may be able to like draw from is if you've ever been in a pool or you've ever been in a lake or a body of water, and you put your head into water, if you hear sounds or someone's trying to talk to you, it sounds very different. And that's not just because your ears have water in them. It's actually because the wave itself, the sound wave that someone's talking to, actually changes when it hits the water, okay? And so someone may be trying to talk to you, but the sound, when it actually kind of goes into water, is going to change in a few different ways, okay? And so that's why it doesn't sound anywhere similar to what it would again above the water in the air. Same kind of thing is one you may have noticed is if light kind of hits a glass window, that kind of stuff, sometimes it can kind of change what comes through. So that light is actually going to, that light wave is actually going to change when it hits the window or other surfaces. Again, when it goes through water, it can change. And so that's kind of our basics of refraction. All right, that's the basic understanding. Let's go through a couple pictures though, and I'll try and tell you exactly what 3 things change, just to kind of show the basics here. So let's go to this one right here for now. So, helpful if I put it up. There we go, now we're good. Alright, so we have a light, okay? This is just like a light, a little laser light that you could kind of have. You can kind of see that it comes in at a certain angle, and the one thing you notice with this is that the angle that it shines at is different. If I were to try and follow, I'm trying to use red, the angle that it might follow would be something like this, but it actually changes the angle. So that's one thing that changes. One thing that changes when a wave goes through a new medium. So you can kind of see this is an air with a glass block. When it goes through this glass block, the actual angle changes as it goes through, okay? You'll notice though when it does leave, when it leaves the actual glass block and goes back to the air, it goes back to its original angle. So this angle and this angle will be exactly the same. It's only going to change when it goes into that actual new medium. Once it gets back out into a regular medium, it's going to be the same. So it kind of be the same as if, and it'd be interesting to try and do this, is if you could talk through, again, water and then have someone on the air on the other side, technically the sound wave when it comes out of the water should be the same. It'd be hard to do, but we could kind of make it work. So that's one picture showing again what possibly could change. I'm going to do another picture that shows a really good thing. This is this. So this is trying to show water waves here, but I'll talk about a few different things here because this could just be sound waves traveling, okay, or light waves traveling, okay. But there's going to be, so you can kind of see that angle changes. You'll notice one other thing that changes here, and it's not exactly easy to see maybe at start, but you can kind of see here, here's our wavelength, and if I measure this wavelength here, it is quite a bit smaller here, okay? So another thing that's going to change is our wavelength. So we have our angle that changes as well as our wavelength, and that's because, again, if it's hard, if the medium is more dense, it's going to be hard to move in that. So the wavelengths are going to get shorter. And the last thing that you can't really show here, the last thing that's going to change is our velocity. And that kind of makes sense as well. If sound is trying to travel through air, it's very easy to travel through air. It's not very dense. It makes it really nice and easy. Well, in water or in oil or in something else, if it had to travel, it's very dense. So it's not going to move nearly as fast in those other things. So here are the three things that change when a wave is refracted, which means it's still going through this new medium, but it's going to change in three ways. It's going to change its angle, it's going to change its actual wavelength, and it's going to change its velocity. All those three things are going to change. Now the only time that the angle would not change is this example here. If, and you guys kind of did this last week, if it is exactly 90 degrees with whatever it hits, so you can kind of see here, if we were to draw our normal line, which is 90 degrees, if it comes in right at 90 degrees, then there's nothing to change, okay? But any other angle, okay, other than 90, again, if I were to draw 90 degrees, this is like 90 degrees right here. Obviously there's some kind of angle here. That angle is going to change over here. It's not going to be the same, okay? Last little picture I want to show you, this one here. So here's an example that you can actually go in, well, you can't go see right now because we're in the middle of January, but you could see in June or July and that kind of stuff, okay? So this is a lake and there's water waves, and so most of the water waves you can kind of see here are moving kind of in this direction, okay? So they're like this, going this way, all right? That is the deep part of the water body, all right? As you get closer to the shore though, well, three things are going to change. First off, our wavelengths aren't going to be nearly as big. They're kind of short here. You can kind of see one here. You can see one here. You can see one here. So that they've gotten quite a lot smaller compared to out there. The speed is not nearly as fast. You can see the speed here is way slower than it would be out there. And you can also see the angle. The angle of these, I mean, if I draw, look, there's an angle there. There's an angle there. It's different than it is over here, okay? This is going quite flat. This angles and changes, okay? So there's just another example of what you could actually see in real life. Again, not now. Again, we usually be playing with some water tables, and we create a deep end and a shallow end, and we get to see it, and it'd be kind of cool. Can't do that this week, but hopefully we'll still be able to work and kind of try and go through this, okay? So there's our basics of refraction. Again, just any kind of wave that goes through a new medium is going to change in a certain amount of way. All right? I just got my light turned off for me. 1 second. There we go. That's what happens when you stay on the same spot. All right, class. There'll be 3 other videos talking about how to kind of do the worksheet questions and work through those. So there you go. Thanks so much. Let's get back to this. All right, we're all good. Thanks so much, class.